Indeed, ready to learn.
That was on the video.
Hello and good day, Officer Damien, keeping control today. We are wrapping up our unit on quadrilaterals with the final four-sided shape that we are going to discuss, and that's a kite. And when you think of a kite, you think of the thing that you fly in the air, and most of you kind of have an image of what a kite is. Actually, kites you fly in the air, nowadays they make them all sorts of different shapes and sizes. But what a kite is, in its truest form, is a four-sided figure where two of its sides are shorter than the other two. Okay, hold on. Let me try
It's a sideways kite.
We are not going to make fun of Mr. Schultz's.
You have a silly looking kite.
Hold on, we're gonna try this again. We're gonna make this very, very pronounced.
I'm not gonna lie, you're pretty bad.
And then we're gonna really bring that down. There we go. There's
I don't think so.
a solid kite right there.
Why is there
Yeah, but like
Anyway,
better than my kite?
if you can do better, then you become a teacher. So the properties of a kite. We're gonna draw a kite showing each of them. Number one, each pair of consecutive sides are congruent. Okay? Each pair of consecutive sides are congruent. Now, we've seen that word consecutive before with other parallelograms, and Travis, we talk about opposite this, opposite that. For a kite, it's consecutive sides. So this pair of sides are congruent, and this pair of sides are congruent. Okay?
What did you say?
Rowan.
Exit, please.
Just face this direction. Max isn't going to talk. Claire and Kylie are going to end their conversation. Okay? We're just going to roll with this. Claire, Kylie, end the conversation. Damien.
Number two, they have two sides that are bigger than the other two sides.
Correct. No, but don't write that down. What? Second characteristic. I'm going to draw another kite, and I'm going to do better this time because I've been practiced now. Maybe if I switch pen color, that'll.
That looks longer than one side.
That's not at all congruent.
No. Why do we have to draw two?
Because we're going to draw three kites. A for practice, because clearly need it. And two, each kite is going to show one of the three characteristics. Diagonals are perpendicular. Okay. And this one we've seen before. This is true also for a square. It's true for a rhombus, and it is true in a kite. Those diagonals are perpendicular. So drawing one straight down, this one's horizontal. Whoops, that shows how bad my kite is. They intersect at a 90-degree angle.
Perfect kite right here.
Thank you. Oh, you're saying yourself. I thought you were talking about me. All right.
Oh, that kite's gonna fly.
And lastly, one more attempt at this. I'm going to try drawing it. I'm going to try going the long sides first, and then the shorter sides.
That looks like a rhombus.
That's
looking like a rhombus to me.
I'm going to go back to what I was doing. Hold on.
Look at that perfect kite.
Why don't you have someone
Let's go
else
like
draw
this.
No, that's
Like
wrong.
this. Can you draw a kite very well, Miss Sherling? You want to come try it?
Yes, you got this. Oh, that's brutal.
Oh, that's erase that, please. That's the worst one. That's horrendous.
The other one.
It's the worst one. That's horrendous.
Go show them up, Mr. Lee.
This is why we only do one objective on kites, so I have to draw them once a year. The third characteristic is one pair of opposite angles is congruent. One pair of opposite angles is congruent. Okay? And the pair that's congruent, this is kind of important. The pair that is congruent are the larger of the two. Okay? They are the angles that do not connect the congruent sides. So like these angles connect the congruent sides, right? They are not congruent. Okay? Not those angles. They're not congruent. The congruent angles would be angles that connect the two non-congruent sides. Okay? Finding the other two involves using the other properties. You can see with, of course, perpendicular diagonals, what we have inside the kite. Right triangles.
Yay.
Oh my.
Here we go again.
Slay.
Questions on these three characteristics? Okay. Let's get to practicing. It says, for each kite below, find the measure of angle G. So each time we're finding G, the question is, how do we get there? Okay.
I'm gonna say it equals 80 degrees.
So, tell me, Damien is saying 80 degrees. This angle G here?
No,
No?
that's 110.
No?
No,
Damien's not.
110? How do you get
that's what I
110?
was gonna say.
So inside is 360.
Okay. So we know that the total inside is 360 because it is a four-sided shape. Okay. We already have 100 degrees and 40 degrees accounted for, so marked. And then what do we know about angle E and angle G? They're congruent, right? So if we label angle G what we're solving for, we label that X, we know that two of them, because E and G are congruent, whatever X is, E is the same, two of that measure will complete the 360 degrees. Damien, turn up. Okay? So 360 minus 140 is 220. 220 equals 2 of angle G, or 2 of X, and ultimately X equals 110. Okay? Angle G in the next one.
There's a way easier way to do it.
What do you got?
You add 100 plus 40, subtracted by 360, divided by 2.
That's exactly what we did, Damien.
Yeah, but that's a lot of work.
Tony, what are you? Tony.
I'm showing every step, Damien, so that if people get lost, they can follow along. If all I did was put the answer, then there would be a lot of questions on how I found that. Let's put it on the back table. Thank you. But yes, what Damien described is exactly what we did here. Rowan?
You want the answer?
Yes.
95.
And how'd you get there?
Oh, I got it. One friend.
Rowan, go ahead.
Okay, so I split it in half and made two isosceles triangles. And then that's 30 degrees, and I added that with 110.
So
It's 95.
So you drew the diagonal. Oh,
I didn't ask you no.
It's not funny.
Wait, I got it.
Yeah, 60 minus 280.
Not even nice.
Shut up.
That's a great
And
next.
it smells. It's 40.
Rowan, so you drew the diagonal in? Is that what you're saying?
I drew the line. Yep.
The way I did here?
Just like that.
And how'd you make two isosceles triangles?
That's not what that is. I made two triangles.
Okay.
Bro, I'm
Yo, photo friend. You're wrong, photo friend.
And then I added,
Hold
so
me.
then you split this 60 degrees in half.
Okay.
30. And I
So
added
this
that-
is 30 and this is 30 here.
I added that to 110.
You added this 30 and 110 here.
Yep.
Okay. So that's 140.
And then you subtract that from 180.
This is so much more
Okay.
Which is 40 degrees.
Yep.
You could just
And
do
then
360
add another
minus
40 degrees,
280.
it's 80.
And then you doubled that to get 80.
Yep.
Final answer.
Alright, so I have an easier one.
No, isn't it? That's not right.
Okay.
Divide by
Joey.
Way more stuff.
So I saw 110, and I know that the one pair of opposite angles is congruent. So the
Yep.
other one is 110. 220
Mhm.
plus 60 is 280, and I did 360 minus 280.
Good.
Got 80.
So our two 120 degree angles, 220 degrees total, plus our other mark 60 is 280. 360 minus 280.
equals 80.
does equal 80 degrees. Okay.
How do you know? Why don't we have to divide by 3 then?
We don't have to divide by 3 there, or by 2 there, you mean?
Yeah.
Because the angles that are congruent are given one of them, so we need the other one. Here, we're actually missing 2 angles, but because they're congruent, that's what we divide by 2 because they're the same. We can get our third angle by knowing this is 110, knowing these angles are congruent, leaving us with only 1 angle to solve for. Here, we were technically solving for 2 angles. That's why we had to divide by 2 because they're the same. But here, we were to get that other angle, get that third angle, and so we're left with only 1 to solve. Right? Every process is a little bit different. I mean, did Rowan take like the ultimate scenic route to get there?
Yes.
Yeah. Okay. But he got there, right?
I mean, that makes sense for him.
Right. And he even, Joey, he even brought up the property we didn't talk about, that diagonal bisects those 2 angles there. Okay? That's important.
He's basically smarter than us all.
The last one, angle G. Tell me what you got. Liesel, tell me how you got there.
I got 60.
And how to get that?
And then, so I added 150 plus 90, and then I got 240. And then I subtracted that from 360, and I got 120. And then you divide that by 2.
And so this time, Damien, this time we're again dividing by 2 because the angle we're solving. He's not a right now. Okay. Any questions on solving for angle G there?
No.
We divide by 2 because we didn't have the 2 angles.
There it is. Rowan, turn around. Don't talk to him. Joey,
I did not say
be the kind kid.
Be the good person.
Be the kind kid.
Would you rather?
Okay. At the bottom.
Anything about it.
It's ice.
You said that one. Twice.
Jack, scoot over. You keep inching closer and closer. Scoot over. What similarities do kites have with parallelograms?
4 sides.
How is a kite different from a parallelogram? What are some similarities? What are some differences? What are you seeing? Backman.
That's
4
4 sides.
sides. Okay. Yeah. Joey?
No sides are parallel.
No sides are parallel. That'd be a difference.
Yeah.
No parallel sides. What else? Kelly.
There's at least 2 sides that are congruent.
That'd be a similarity.
Yes.
Okay. So parallelograms have both pairs of opposite sides are congruent. That's true for parallelogram, rhombus, and rectangle. That would probably be difference. It's got only 1 pair of parallel sides versus 2. That's where it kind of falls in the same family as a trapezoid. It's got 0 pair of parallel sides, no parallel sides. We already had that one. What'd you say, Kylie?
Congruent.
Oh, congruent. Oh, okay. So with parallelogram, it has those opposite congruent sides. Kites have consecutive congruent sides. Sorry, rather than opposite. Okay. What else? Yeah.
Interior angles add up to 360 degrees.
Sure. Okay. An interior angle sum of 360. Anything else? You may want to add down there that the diagonals intersect at a 90-degree angle. That's not true for all parallelograms, but it is true for 2 of them. Okay, so there's a similarity there.
So it doesn't work. That's not all. So.
True, but I mean, if you want to note, that is true for 2 of them. Rhombus and these are your own notes, like that. On the second page, this is going to be your homework for Tuesday. You've got 3 figures here, And on each of them, you need to find WX, XY, YZ, WZ, and angle WXZ. Your answers, this is the Ellen special, must be written in simplest root form.
Good job, Al.
No, I had that written obviously before, because I reprinted anyway. But you cannot round. Okay, simplest root form. So let's just do the first one together here. I don't know how well these diagonals copied off in your binders. Sometimes they're better than others. Okay, so you might want to draw them in. But every kite has the diagonals. Okay,
There's a kite right there.
that's a good kite. That's a very good kite. Yeah, they're much better at drawing kites than I am. So tell me how we're going to get side WX here. Our first task, WX. We could use the Pythagorean theorem. What else could we use here? Could use 45, 45, 90 triangles. How do we know it's a 45, 45, 90 triangle? Because these intersect at a right angle, but how do we know it's specifically a 45, 45? Because the legs of this right triangle are congruent, right? It's not 6.
It's gotta be 7.
3 root 2.
What? How did you get that?
Because the ratios for a 45, 45, 90 triangle are n root 2, right? The legs are congruent. The hypotenuse is whatever the leg is times the root 2. So identifying this as a 45, 45, 90 triangle, we know that hypotenuse has got to be 3 root 2. If you use Pythagorean theorem, okay, that could also work. You would set it up as 3 squared plus 3 squared equals c squared, or 9 plus 9 equals c squared, or 18 equals c squared, or c equals the root of 18, because you root both sides to get c by itself. How do we get 3 root 2 out of the root of 18? 4 times 4 is 16.
I mean,
The measure is 9 and 2.
9 and 2, right?
oh.
Root 9 times root 2, or 3 root 2. So either way works, but you do need your answers in simplest root form. The most efficient way is knowing those 45, 45, 90 relationships, okay? But if you didn't, the Pythagorean theorem also does get you there. It's just a lot more steps. All right? Let's talk about XY first.
I didn't figure that one out.
How do we get XY?
Yeah. 3 root 2.
3 root 2. Why would XY also be 3 root 2?
Because it has 3, it's 45, 45, 90.
It's got the same legs as the other right triangle we just worked with. And what do we know about a kite and this pair of sides?
They're congruent.
They're congruent.
I'm on fire.
Okay? So if WX is 3 root 2, then XY is 3 root 2 as well.
And we know.
YZ would it be?
How can you use the Pythagorean theorem? Because we know it's a right triangle because these diagonals bisect, or not bisect, intersect at 90 angle. Here's your A, here's your B, the hypotenuse is C.
Oh.
No, you can't. But when you use the Pythagorean theorem and you get down to the root of 18, which when you root both sides, you get C equals root 18, then simplifying the root, folks, simplifying the root, you're looking for 2 factors, one of them being a perfect square. That's your 9. That root 9 simplifies to be a 3, and then you have your root 2 that tags along. Okay, so that's how you get 3 root 2 using the Pythagorean theorem. Does that make sense? Okay. XY, again, it's the same. YZ, how can we get YZ?
I have no idea. But I'm going to take a wild guess. And I'm going to say,
What's that? Pythagorean theorem.
how do you
Okay.
do that?
You've got a right triangle. YZ is the hypotenuse of this right triangle.
It's got to be greater than.
The legs are 3 and 5, so we are going to plug in 3 and 5 into our Pythagorean theorem. And we know that 3 squared plus 5 squared has to equal the hypotenuse squared.
Oh, I know.
Okay? So 3 squared is 9.
25.
5 squared is 25.
34.
Hold on, I can't think as fast as you can talk.
34 and 5.
9 plus 25 is 34.
Haha.
Way to flex. And then to get c by itself, you're going to root both sides. And so the square root of 34,
I just got it.
can it be simplified? No.
It's
There's no
5.8.
The Dame time special, okay? If you can't simplify it, then the root of 34 is going to stay the root of 34. And so that would be your answer for YZ.
Thank you.
We use the Pythagorean theorem to find that. You're also has to find WZ, which if
Same thing.
YZ is root 34, WZ is going to be
34.
root 34.
Yeah.
And then finally, WXYZ.
Oh,
WXYZ is this. WXZ, sorry. WXZ is this angle here. It goes from point W up to point X. X is in the middle, that's the vertex, and down to point Z. So we're looking for this angle right here. What's it going to be? Christopher?
45 degrees.
How do you know that?
Because it's a 45, 45.
We've already determined it's a 45, 45, 90 triangle, right? That's how we got this 3 root 2 in the first place. So WXZ is going to be a 45 degree angle. What if it wasn't a 45 degree angle? You can use the inverse of sine, cosine, tangent to find it there. How is it 45, 45? Because we know it's a right triangle, right? And the two legs are congruent, therefore it has to be. Okay? So again, you are using all of these tools in your toolbox and applying it to different scenarios.
Scenario.
Hi,
Man, you are just
different scenarios.
Scenario.
Goodness gracious. You are a tough crowd.
Okay.
Okay. Your homework for Tuesday is to finish the objective. You've got 2 more to do, but several to solve for. I do want your work to be shown. If you don't show your work, you will not get credit. Obviously, for ones that are congruent, once you find WX is 3 root 2, XY, there's no work to be shown because it's the same thing. But if you use the Pythagorean theorem, I want to see the Pythagorean theorem. If you use sine, cosine, tangent, I want to see that. If you use the inverse, I want to see that. Show me how you find answers. If all you have written down are numbers and no work shown, then you're not going to get credit. I need to see. I want to see how Rowan solves these questions. That's what I want to see. I want to see the thought process that goes into this. Okay? Then Tuesday, you'll get your practice test. You'll have all weekend to do it. And then we'll have our test when you come back from camp, which is May 1st, by the way.
my birthday.
That is how close to the end of the year we are. I will not see you again after Tuesday until May. That's just insane.
Let's go.
All right, that's how I'm at.
Don't forget to like